these exponential functions from a table. And so it's super important that you remember that this is our function, y equals a times b to the x, okay? You can also see it a couple different ways. You could write it as y equals a b to the x without the little multiplication sign. You also can see it as y equals a times b to the x, okay? So you can see it a couple different ways. You can write it all those ways and it's totally acceptable. And the super important thing is a is that y value of that y-intercept, okay? That's going to be our y value of the y-intercept. And b is the multiplication pattern of that y values. Okay, it's our factor. So you can also think about it, this is the same thing as that ratio from our geometric sequences that we just did, okay? This is going to be the same thing as that ratio. So, all we have to do is identify the a and the b, and then we can write our equation. So in this particular problem, let's look at our table. Now, for some reason, I forgot to number them. I apologize. So I'm just going to do it right now. This is number 1. All right? Number 1, what is my a value? We look at the table. We want to find when x is equal to 0. So what is a equal to, y'all? 27. So my a is equal to 27. Okay? What is my b value? What are we doing? What is the multiplication pattern? What is the ratio to get from 3 to 9? Multiplying by 3. Now let's double check it. 9 times 3 is also 27. 27 times 3 is also 81. We are multiplying by 3 times every time. So this right here is my b. So guys, if we know the a and we know the b, can we write our equation? Yeah. So this becomes y equals 27, because that's our a value. And then I like to put it in parentheses, times 3 to the x. You don't have to. I like to do that because then I won't screw it up when I put in the calculator. But you do not have to. You can do 27 times 3 to the x as well. Now what I recommend doing is you go back in here, go to your y equals, and actually type this in. Okay? 27 times 3 to the x. I'm going to go to my table values, and I'm going to check them. Okay, negative 2, 3, negative 1, 9, 0, 27, 181, and 2, 243. These tables from this equation that I just wrote are the exact same thing as the one that's given to you. Now guys, if you choose just to do the little times button, the little dot button, it will still give you the exact same values there. Do you see that? It just gets a little tricky with fractions, so that's why I like the parentheses. Alright? Y'all feel good about this? Now one thing I want you guys to recognize is this b, does this represent growth or decay? If it's 3, is that bigger than 1 or smaller than 1? So that is growth. Look at your table. Is my table growing? Are my y values getting bigger? Yes. So it's growth and it's growth. They match. Isn't that beautiful? Okay, guys? So you can see that if your numbers are getting bigger, it's going to be growth. All right? So let's take a look at this number 2 here. Okay? So number 2, I guess that was number 1. Number 2. When you look at this, do we have our y-intercept on the table? Are we given a 0 for the x? No, we don't know it. That kind of sucks. We're going to have to find it. We're going to have to do a little backwards math here, but we can find it. So what I want you guys to recognize is since we don't know our y-intercept, what is my growth factor? Well, I kind of gave it away. It is growing, right? Because the numbers are getting bigger. So what are we growing by to get from 625 to 3,125? Okay, how'd you do that? You did 3,125 divided by 625, and we get 5. So we know that we're multiplying by 5 each time. I like to double check, and I'm going to do 3,125 times 5, and yep, sure enough, that is what we got there. Do y'all feel good about that? Okay, so now if I want to find my a, then guys, I'm going to go backwards. So going forwards, I'm multiplied by 5. what do I need to do to get this guy right here? Divide by 5. So what's 625 divided by 5? Oh, 125. Now that we've done that, do I have my y-intercept? I sure do. So this right here is my A. This right here is my B. Can I write an equation? Yeah. It's y equals 125 times 5 raised up to the x power. And guys, yet again, because you can never be too sure, it's really easy to make those simple mistakes. I would check it in my table, and I would say, cool, okay, 1, 625, 2, 3,125, 3, 15,625, 4, 78,125. Yes, they match, okay? So I would check it in my calculator and check my table there, okay? You can never really be too sure with that. And what do you notice? Is this going to be growth or decay, y'all? Growth, which makes sense because my numbers get really, really, really big, right? And if you tried to graph this on your calculator, I don't even think it would show up because the numbers are so big, right? Or I guess it does a little bit right there. Because where is it going to cross through the y-axis? Way up there at 125, right? So it shows up here. It doesn't even touch our y-axis until 125. So that one's kind of interesting. All right, now let's take a look at this. All right, let's look at these two. So, can we recognize our A? What's my y-intercept, y'all, on number 3? Is it just 1? Do you guys feel good about that? That's my A value. Okay. What is my B value? What's going on to get from this one to the next one? What am I doing? To get from 5 to 1, dividing by 5, or multiplying by 0.2, okay? So you're dividing by 5, or you're multiplying by 1/5, or, as Alex said, you're multiplying by 0.2, okay? Because 1/5 and 0.2 are the same thing. Do y'all feel good about that? So we are dividing by 5, which means we're really multiplying by 1/5. Now, just to make sure we're on the right track here, I'm going to do 5 times 1/5. Yep. 1 times 1/5. Oh, that's not right. 1 times 1/5. There we go. Ooh, that's 0.2. 1 times 1/5. And then 1/5 times 1/5 gives me 0.04. And if we turn that back into a fraction here, yep, that sure is 125, okay? 1/25. All right? So if we have our A value, that's going to be y is equal to 1 times, I would say 1/5 to the x power. Now here's the thing, guys. You really actually don't need that 1, so you can just write this as 1/5 to the x, or 0.2 to the x. Okay? And what I want you guys to recognize here is this growth or decay. It's decay because it's less than 1. If it's less than 1, it's decay. We type this in, 1/5, I'll do it in parentheses, 1/5, what? Raised up to the x power. When we look at our table here, we see, okay, -1.5, 0, 1, 1.2, 1.04. Yeah, so we see all that our table values match these table values here. Okay? If we had typed it in as a fraction, it would match it perfectly, which would be very nice. Match it with the fractions and everything. Be the 1/5 and the 1/25, and you can keep going. Okay? So that is a very, very good check. Always type it in and check it. Alright? Number 4 here. Alright, this one's interesting. What am I doing each time here? Are my numbers getting bigger or smaller? Smaller. So this better be decay, right? Because it's getting smaller. So my B is going to be less than 1. So what am I multiplying by to get from 1.25 to 0.3125? So I'm going to go 0.3125 divided by 1.25, and I get 0.25. If I turn that into a fraction, what do you know? What am I multiplying by? 1/4. Okay? And that is actually what happens here. We do 0.3125 times 1/4. Oh, so I'm multiplying by 1/4 every time. Now guys, so this is my B value, which is wonderful. Okay, do we know our A value? No. So we got to go backwards. So guys, if I'm multiplying by 1/4 to get these, what am I going to have to divide by to get that guy? Divide by 1/4. Or you could just say multiply by 4. So 1.25 times 4, that is going to give me 5. So this right here gives me my y-intercept of 5. Do y'all feel good about that? So this becomes y equals 5 times 1/4 raised up to the x power. Y'all feel pretty good? Excellent. Alright, so 5 times 1/4 raised to the x power. If we typed it in, we would see that our tables would match. We see that that 1/4 represents decay. Alright? So really, the two things you need when writing an equation from a table is the y-intercept and that ratio, or that growth. The growth or the decay factor. Do y'all feel good about that? Excellent. Okay, so we actually have a lot of time. You guys can go ahead